We are on the very last lesson of Module 9. That's going to be Lesson 4, which covers the surface area of pyramids. Now, once again, we don't have a whole lot of new material here. We're going to be doing the same exact thing that we did in all of the previous lessons, except maybe Lesson 1. I don't remember if we did any surface area there. So, what did we know? We know that our pacing guide claims this is going to be a 90-minute long lesson. There are 14 resources to get through to learn this one, so let's get started. Surface area pyramids. Did you have a swing set in your backyard when you were younger? There are many different types of swing sets, and they all have different sections of activity. Some swing sets have a pyramid-shaped climbing section that has different activities on each side. Ladders, rock walls, cargo nets, things of that nature. How could you determine the amount of wood needed to create a pyramid-shaped climbing section? These are some of the things we're going to learn about in this lesson. We are picking up some new vocabulary terms today, the first of which is going to be a pyramid. A pyramid is a three-dimensional figure that has one polygonal base and triangular sides that meet at a point. Highlight that one. The sides of the pyramid are called the lateral faces. Highlight that one. A regular pyramid has a base that is a regular polygon and has lateral faces that are all going to be congruent. So, for example, the Great Pyramid of Giza, it is going to be a regular pyramid because it has a base that is a regular polygon and the lateral faces are all congruent. The height of one of the lateral faces of a regular pyramid is known as the slant height of the pyramid, and the slant height also divides the base into the triangular face the slant height also divides the base of the triangular face in half, creating two congruent segments. A square pyramid is a pyramid with a square base, as you can see in the illustration right here. And four triangular faces. The triangular pyramid is a pyramid with a triangular base instead of a square base, and three triangular faces. The base of a regular triangular pyramid is going to be an equilateral triangle as well, meaning all sides will be equal or will be congruent. Now, just like all the other polyhedrons that we've been finding the surface area of, the first thing we have to do on the pyramids is make a net. And the pyramid is the absolute easiest net to make because all you have to do is lay out the base and then boop, flop down the sides of it and you're done. It's really a very easy net to get to make here. So, the instructions say draw and label the net to represent the pyramid. How are they going to have us do it? Probably going to be pretty similar to the others we've done. So they've got your grid paper here, and they say first off, what's the dimensions of the base? Well, the base is 4 centimeters by 4 centimeters. So we're going to type a 4 in here and a 4 in there, and we're going to hit check. That part checked. Next, they took and laid out that base, and you can see on their grid paper the base covers 4 square units or 4 units in each direction, making it 4 by 4 squared, also known as 16 square units combined, but we're not really worried about that at this point. Next, they're going to have to take and lay out the 4 sides of those triangles, and I believe they call those lateral faces. So we're going to click the next button again, and they want us to find out that, okay, the dimensions of the base, the dimensions of the lateral faces. Well, each one of those are going to have a base of 4, so we're going to put 4 in for the base, and the height. Remember, in a triangle, the base and height meet at right angles, so you're going to start at the center and go up to the peak of it to find that the height of that is going to be 7.23 centimeters. So 7.23 centimeters is going to be the base and height of the triangle. That part checked correct. And now you can see they laid out each one of those faces of the triangular prism, or rectangular prism, excuse me. And that now you have a net completed. It's really all there is to making the net on this. No more questions to answer on that one, I don't think. Nope, the net is going to be complete. Pretty easy to do, right? And once again, it's going to be your turn to pause the video, work extra example number 1 on your own, where you're going to select which one of these nets is going to be an appropriate net to go with the triangular prism. So how did it go? I'm sitting here looking at the rough drawings, and each one of these drawings themselves are perfect nets. There's nothing wrong with how they're all laid out, because they will all fold back up to become that square pyramid again. What we need to look at then is going to be the dimensions. So the first thing I want to see is the dimensions of my rectangle, or my square in this case, are going to be 10 by 10. So we can look and say that A could be a 10 by 10, and that B can be a 10 by 10. So both of those have a 10 by 10 base there. And then this one here, that's 13 by 13, and this is 12 by 12. So C and D cannot be valid ones. Next, I want to take a look at my slant height. And the slant height is going to be this distance going down the center from the base to the peak of our pyramid. And that is going to be a slant height of 12. You can see A has that same slant height of 12, but B does not. B has that slant height of being 13, so we can take that away, because 13 is going to be the length of the side right here. We don't care about the length of the side. It has no value to us. A is going to be your only correct answer in this problem. Example 2 wants us to do the same exact thing, but this time we have an equilateral triangular prism, or pyramid, excuse me. The base is an equilateral triangle. You can see all 3 sides of the base are going to be 9 meters. That means that the sides, of course, of each side or lateral face of that triangular pyramid is also going to be congruent to each other, but they're not going to necessarily be congruent to the base. They might be, they may not be, but we do know they're all going to be congruent to each other. Actually, look at that. They are going to be congruent to everything because they all have the same height, or lateral slant height, excuse me, of 7.8 this way, 7.8 that way. So all 4 of the triangles involved here, they're going to be congruent. When you take to make the net of it, let's take a look at the questions they have for us. First question, the base length, 9. So we have a base length of 9, and the height, that's going to be this distance right here. That's going to be your 7.8 meters. So we put in our 7.8, and we're going to hit check. Way down there at the bottom, that checked. Now we're going to go on to the next one, where they have taken and laid out the base, which has side lengths of 9 and a height of 7.8 meters. From there, the next questions they have is the lateral face base. That's going to be each one of these ones here. They are also going to be 9, and the lateral face height, also known as the slant height, is going to be the same 7.8, because all the triangles in this pyramid are going to be congruent. From there, they took and laid out all of those, and hey, that's pretty cool. It made out an even bigger triangle. And finally, from that, they would say that, yep, your net is complete. That's all there is to doing this. Now, once again, it's going to be your turn. Pause the video, see how you end up doing on this one. So how did it go for you? Let's take a look. You've got all 3 of the drawings that they give you on the surface look fairly good. They're all triangular bases with 3 sides coming out from each of them. Each of the 3 sides are triangles. I'm sitting here thinking this one here, that just looks bad. It's not even close. But let's see what we've got. First off, the center triangle is going to have dimensions that are going to be 4. So all of the sides are going to be 4. And this height right here, that's going to be 3.5 feet. So let's take a look. This one has a height of 4 feet and side lengths of 5. That's not going to work. This one has side lengths of 4 and a height of 3.5. So that's a valid option. This one here has a height of 3.5 and side lengths of 4. So that's a valid option. And this one right here, it looks like it has side lengths of 3.5. That's not going to work. So we're down to B and C. Next, if we take a look at our triangular pieces here, these lateral faces, you can see that you've got bases of 4 and heights of 5. So with this one, this has a, we're looking at B next. So this has a base of 4 and it has a side length of 5, but it doesn't say that it has an actual height of 5, so B cannot be a good answer. Moving on to C, this has side lengths of 4 and an actual height meeting at the right angle going from the base to the vertex. That's going to be 5, so C is going to be our only correct answer on this problem. We're going to finish off part 1 by watching a video on how to find the surface area of various pyramids. After that, we're going to come back for part 2 and we're going to actually apply those skills on about 4 different problems just to make sure you're pretty darn rock solid on how to use them. So let's watch the video they gave us.
The surface area of a three-dimensional figure is the sum of the areas of the faces. To find the surface area of this pyramid, find the sum of the area of the base and the areas of the lateral faces. You can use a net to find the surface area of the pyramid. The shapes in the net of this pyramid are a square base and the 4 lateral faces. First, find the area of the square base. Multiply length times width. Next, find the area of the lateral faces. The base is a square, so the area of each triangular face will be the same. Find 1/2 of the length of the base times the height. Finally, find the sum of the area of the base and the areas of the lateral faces. The sum is 132 square centimeters. So, the surface area of the pyramid is 132 square centimeters.
They gave some really good supporting work on that. They started off with their formulas for each problem. They showed you how they added them all up. The only thing I would really change is I would make sure that when I found the area of a piece, I would write that number in on that piece on my net so that I could keep better track of what I was doing. That is it for part 1 of this video. Come back and watch part 2 next, where we're going to apply the skills we just learned in this short little clip about how to find the surface area of various pyramids. I'll see you there.